In the previous video, we talked about feature branches and how they help with testing and development. We also mentioned that we would expand this topic by demonstrating how GitOps can be applied to environment management. In this video, we will cover the GitOps approach, its benefits, how it's implemented in KubeRocketCI, and apply this approach to an environment. Let's start with the basics. The core idea of GitOps is to store and manage the desired state of an application in a Git repository as a single source of truth. Depending on the team and project, a GitOps repository might store infrastructure as code templates, application code, Helm chart configurations, and more. The planned GitOps approach brings a bunch of benefits. In a GitOps repository, updates are applied via commits and pull requests. This means you can easily track what changes were made, by whom, and when. If anything goes wrong, rolling back becomes a straightforward process. Additionally, GitOps helps improve security by narrowing the scope of access. Instead of giving users direct access to environments or clusters, you can manage permissions entirely through Git. To understand GitOps advantages better, let's look at a real-world use case. Imagine you have a CI/CD flow with several environments: dev, QA, and prod. Each environment requires unique Helm chart parameters for the application, such as replica counts, external endpoints, resource requests, etc. Without GitOps, managing these environments becomes complex. You would need separate deploy pipelines for each of them. With GitOps, you can use a single deploy pipeline for all the environments, simply modifying their parameters using a configuration file stored in a GitOps repository. In this scenario, GitOps simplifies not just deployment, but also environment management. Now, let's see how GitOps works in KubeRocketCI. In KubeRocketCI, the GitOps repository acts as a shared codebase. Like any other codebase, it's listed under the Components section, where you can open and view its contents in Git. After creation, it can't be deleted from the KubeRocketCI portal as it's considered as a system component. You can delete it only via kubectl commands. Just as other codebases, it has its own review and build pipelines. The only difference is that a build pipeline doesn't build any artifact. Its functionality is the same as for review pipeline. It validates YAML syntax and structure to ensure everything is correct. There are two strategies for creating a GitOps repository: create and import. However, unlike other codebases, GitOps repositories are created in the configuration section of the portal. It's worth noting that KubeRocketCI itself is built and configured using the GitOps approach. Instead of creating pipelines with the Create Resource button right in the KubeRocketCI portal, you can manage your pipeline definitions in a Git repository, then import them into the platform as a codebase of the library type. This allows you to fully version and control your pipeline configurations using Git. Another convenient option is to use our add-ons repository, which you can fork into your own account. There, you can set up configurations for most integrations supported by KubeRocketCI, making setup even faster and easier. This flexible approach lets you choose the best configuration workflow for your team. The GitOps repository plays a key role during application deployment to environments. Creating GitOps is a prerequisite for creating deployment flows. It allows to redefine the application Helm chart parameters. To make environments use the GitOps repository as a source of truth, you need to enable the values override option. When it comes to deploying an application, the platform checks if the values override option is enabled. If it is, the system navigates to the GitOps repository, locates the corresponding file, and applies the parameters defined there to override the Helm chart values. One GitOps repo stores all the redefined parameters for all the environments on the platform. To keep the repository contents organized, it strictly follows a specific file structure. To redefine the parameters for application Helm chart, you need to stick to the following pattern. Firstly, create a directory with the same name as the deployment flow you want to redefine. Secondly, inside that directory, create another folder with the same name as the environment. And thirdly, create a file named application-name-values.yaml. So the resulting pattern will be deployment flow name / environment name / application name-values.yaml. Now that we understand what GitOps is and how to use it in KubeRocketCI, let's put theory into practice. Together, we will create a GitOps repository, configure values, and adjust the environment. Navigate to the portal. In this demo, we will be using the orders processing application. Navigate to the deployment flows section. If now GitOps repository created, we are expected to see this message. Clicking the link below will immediately get us to the GitOps repository creation page in the configuration section. On this page, click the Add GitOps repository button. On the appeared window, select the available Git server, specify the account name, repo name, and click Save. Okay, great. Now let's quickly create a deployment flow for the application. Navigate to Deployment Flows. Now we can see that we can create deployment flows. Let's click the Create Deployment Flow button. Specify a name and description and click Next. Select Application, Branch, and then Create. Go to Deployment Flow. Here, create a dev environment. Click the Create Environment button. Specify environment name, description, and click Next. Create, go to Environment. Now let's deploy the application as usual. While the deploy pipeline is running, let's quickly look at the Helm chart parameters for the application in Git. They are defined in the values.yaml file of the deploy templates folder. According to the default configuration, it deploys only one replica. We are going to change this parameter using GitOps. Now let's get back to environment. Okay, as we see, the application is deployed. Let's check the amount of replicas in the Argo CD application resource. Click the Argo CD button. Select Application. Indeed, there is only one replica. And we are going to change this by increasing the replica count using the GitOps repository. Get back to the portal. Click the Go to the Source Code button to open the GitOps repository. GitHub shows that the file is not found. It is absolutely expected because the file is not created yet. Open the Code tab. Now we need to create a pull request where we will add the values.yaml file for the application. We will fast forward this process to save time. Okay, now we have a pull request with a file with new values. Review pipeline is completed successfully. In the root folder, we created the order flow/dev/ordersprocessing-values.yaml file. In that file, we redefined the amount of replicas, so there will be 3 of them. Let's merge the pull request and wait until the build pipeline is complete. We will fast forward this process. As soon as the build pipeline is complete, navigate to the deployment flow and deploy the application using the values override option. In Argo CD, we can observe how 3 replicas are being created. To sum up, today we learned what GitOps is and how it makes managing deployments and environments easier. We saw how KubeRocketCI uses GitOps for configuration and automation, and we practiced managing environments, customizing deployments, and overriding configuration values using the GitOps repository. That's it. Thank you for watching.